so these two sections are called measure, position, and box plot. It's a pretty straightforward section, so we're just going to talk about it here and then go for it from there. Okay, right. So just go talk about this. So a statistics with a characteristic of description of data by describing its shape. So we talked about shape itself, right? So skewness, symmetric, and all that fun stuff itself. And listing some of the descriptive stats. So everything we've done so far is describing stuff. So we'll get to the nitty-gritty stuff actually in a little bit when it comes to this class itself, such as the measure of center and measure of variation. So those are the last two sections, right? So center being mean, median, and mode, and measure of variation is standard deviation and variance, okay, when it comes to it. Now we're going to talk about a little different type of measures tendency, so aka a typical range, for a distribution of data. So that's the mean and the median. So we're going to talk about the median far more in this section when it comes to it. So technically, statisticians do not measure variety about the median. However, we can use the 5-number summary and box plots to signify spread when it comes to the median itself. So that's a key thing. And this is exactly what we're going to be doing in this section, something called a 5-number summary and a box plot. So introduce that kind of stuff. We're going to do a quick little exercise here. It says find the mean of the data set, mark the median on the data set, and then find the median of the lower half of the data set and the median of the upper half of the data set. So let's just first find the median, right, which is, easy stuff, right? We just go crisscross, crisscross, crisscross. So if you just go back and forth, you just go down the middle, right? And you'll see it's actually between these two numbers here, 11 and 13. So remember to find the median, add them up and divide by 2. So our median is exactly 12, right? That's our median. Okay. Now it says to do a couple of things, right? We want to find the median of the entire set. So that's exactly what we did. But now it says find the median of the lower half and the upper half. Okay, now what that is saying is if I have a median like a marker, like I have it there, so now it cuts the data set into two parts, the lower half and the upper half. So now we want to find the median of from 3 to 11 and then from 13 to 18. So just do that again, right? Crisscross, crisscross, crisscross. And we should get, I believe, 6 as our median for our lower half. And if we do the same thing on the other side, crisscross, 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 we should get exactly 16.5 for there. Okay, so that's what that meant by, the upper half. Now, when it comes to the medians, this type of portion, think of it as a hard line, right? So notice I did not include 12 in either one. It's a hard line, so all the numbers before it is in the lower half, all the numbers after it is in the upper half itself. Okay, so now that we have that done, let's see what it says. So you just found the quartiles of the distribution of the data set. So we'll talk about what it means by quartiles. So the quartiles always divide the data set into 4 groups, kind of like the quarter system, in our number, in money-wise, right? You can think of quarters and quartiles, hence why it's called almost identically, right? With equal counts of data values in each group. The median is the second quartile, or Q2 for short. So if it's Q2, therefore, we have Q2 being 12. So let's think about this real quick. So if Q2 is the median of the entire data set, and it's called Q2 here, and it's quartile, right? It's half of it. So what do you think Q1 represents? Hopefully you guys get it right. It's going to be the median of the lower half, right? So kind of like a quarter system, right? So this is going to be 6, and therefore Q3 is probably going to be 16.5. And the last two things is the minimum and the maximum. Well, minimum number we have is going to be 3, and the maximum number we actually have is going to be 18. Okay. So there you go. We got our 5-number summary. And that's how we find our 5-number summary. Pretty straightforward, right? You literally just find the median 3 times. Those are your Qs, minimum, maximum, hence the 5 numbers themselves. So believe it or not, that's half the way of this section is all about. Okay. Now, next thing is, well, what does this represent? So, that's when it comes to what do these actually mean? So because 2Q3 is the median, therefore 50% of all the data values are below it and 50% of all the data values above it. So by this logic, we can kind of represent what Q1 and Q3 represents, right? So like I said, like a quarter system. So for example, 1 quarter represents 25%. So that's exactly what this means. So 25% of all the data values are at or below the Q1 value. Okay, so for example, if I want to write this in a sentence, we say 25% of all the data values are out or below 6, because that's the Q1 value itself. Okay, so we talked about Q2, right? So 50% of all the data values are at below Q2 value. And then for Q3, it's going to be a quarter system, 75% of all the data values are at or below the Q3 value. So for Q2, 50% of all the data values are at below the value of 12. For Q3, 75% of all the values are at or below 16.5. And that's how we interpret these values themselves. Okay. All right. So now let's put this into practice, right, when it comes to it. So let's try the back. So example 1 says, a list of assorted budgets amounts in the millions of dollars for a simple random sample of movies is listed. Find the quartiles of the data set. Okay. Right. So we'll just find the quartiles, right? So, all right. So let's see. So if we crisscross, crisscross, crisscross. So I believe we should be between 35 and 40. So that's going to be exactly 37.5 once you add them and divide by 2. So we know Q2. So notice you find Q2 before find all the other ones. So Q2 is going to be 37.5. So now remember, so it's the lower half. So now we find the median from 4.5 all the way to 35. So just going down the middle, and I believe that's going to be 20. 20. And now do the same thing in the upper half, from 40 to 70. And I believe that's going to be 52. And that's it. We got our quartiles. So hopefully not too bad, right? This is a nice little section to end the chapter off when it comes to it. So why don't you guys try number 2, hemoglobin in cats. So that's the blood in cats. So I'll give you 3, 2, 1, pause. Try it. Okay. So hopefully you guys tried this out, and hopefully I did not trick a lot of you guys, because this is very tricky. Because remember, how do you find the median of a data set? You first have to put them in numerical order, and notice they're not in numerical order. So if you just went from that portion, all of these are actually wrong. So you have to put them in order first. So 5.7 comes first. Then I believe it looks like 7.7. Then I believe it's 8.9, 9.4, 9.6, 9.9, 10.6, 10.7, 11, then it's 11.7 and 13.4 in order, right? So you got to make sure, right? You have to put them in increasing order first before you find the Qs. So once you have that, hopefully you guys got your Qs. It should be 8.9 for your first one, 9.9 for your second one, and then finally 11 for Q3. Okay. So that's how you find quartiles of a data set. Okay. So let's go on to the next part of the sections is box plots. So a box plot is pretty much a graph using the 5-number summary. So it uses the minimum, the Qs, and the maximum. Now how this is made, it's probably one of the easiest graphs you're going to deal with is you're going to have a scale on the bottom. So this goes from 5 to, let's, I don't know, 100, right? And we're just going to scale it. And how this works out is you're going to draw the 5-number summary. So you're going to put dots on your minimum, your Qs, and then your maximum number. So just make dots and so they're not actually on the line, they're above the line. And next thing you're going to do is draw a line between them, so connecting all of them as straight as possible you can. Okay. And the reason why it's called a box plot is you're going to make a box over your Qs, looking like that. And there you go. That's called a box plot. So this is your minimum value, your Q1, Q2, Q3, and then your maximum value. The key thing is, right, notice it's a scale on the bottom. This does not go on the scale, it's above it, okay? But you do need these ones when it comes to a box plot itself, okay? Right? So, not too bad, right? Very simple graph when it comes to it. Well, what we're going to do now is the last part of this section is something called outliers, okay? or extreme values when it comes to it. So these are values that are far out the norm than we may actually see in the real world. Okay, so now we're going to talk about, going back to the empirical rule, why is it only 99.7, not 100%? Well, we may have something called an outlier when it comes to it, and we're going to define what that means in the next one.